Hello everyone, greetings. My name is Ambar Prajapati and today I'm going to present you my article Amqp and Beyond. I begin with Industry 4.0. As we all know that Industry 4.0 has been shaped by many technical evolutions like IoT, smart sensors, robotics, automation, data analytics, augmented virtual reality, 3D printing, wearables, safety innovation, cloud security, cybersecurity, edge computing, etc. So, when we talk about these diverse things, we really talk about how to integrate data sources so that we achieve interoperability, reliability, autonomy, and decentralized control. Well, the solution already came in the form of Advanced Message Queuing Protocol AMQP. It was launched way back in 2006 and it became our OSS standard in 2012 and iOS standard in 2014. So it offers connectivity via broker services. It offers multiple conversations, flow control, recovery, message filter, and firewall. And it offers fault tolerance and can process large data volumes in short time. So we begin with the unit of work, which is an AMQP message. And the messages are independent encapsulated data entities with a header, body, including a routing key. These messages flow like a stream of bytes, making any compliant system interoperate regardless of its native language. The entire integration concept revolves around passing the messages safely and reliably via a shared queue space accessible to all participating systems. When we talk about integrating diverse systems, we need to talk about architectural patterns so that the combination can result into a meaningful, sustainable solution. So we talk about some of the patterns that are feasible with AMQP, like publish subscribe, direct messaging, event streaming, request response, peer-to-peer, store and forward. Let's have a look at them one by one. So the messages are actually published events and when we talk about the pub/sub pattern. So they are the notifications to applications and they can have data structures. And the applications which are subscribing to these notifications can respond to the events by executing certain tasks or modifying the state. And the events may come and go, and the AMQP broker will ensure that there is a proper event flow among the partnering systems. The direct messaging pattern provides unicast message routing. The consumer application receives the targeted message to act further, and it is also helpful in round robin scenarios where each application can communicate with all other applications. Event streaming can be built by applying APIs and development stakes on top of AMQP to support reliable event streaming pipelines and stateful and stateless streaming solutions. The request response messaging pattern typically uses HTTP URL to send RESTful services to execute a task and or modifying the state at the server. The server can respond with a result of the requested action and they may or may not exchange a data model. Next, we talk about peer-to-peer multicast messaging pattern, which allows various applications to connect without requiring a server. And the peer-to-peer method is actually helpful to implement clustering and grid-style networks. Store and forward messaging pattern provides fault tolerance, as the name suggests, stores. And whenever the recipient application is ready, it forwards the message when the service has returned back to its active state of participation, which is typically during high latency situations. Then we talk about AMQP as an integration partner. Sorry. So in a broader solution, when there are subsystems employing other protocols like MQTT, COAP, HTTP, STOMP, or other protocols like open information formats, or even in a multi-protocol system, AMQP can create a binding to further extend a solution. So let's take them one by one. MQTT is a OSS standard protocol, which is especially suitable for high latency and unreliable networks. Now, AMQP's multi-topic feature extends its capability of binding to MQTT and opens the integration functionality to the lightweight, remote, and small network bandwidth devices offered by or supported by MQTT. Constant Application Protocol is a specific web transfer open protocol. Again, it is used for constant nodes and constant networks like in IoT and machine to machine applications such as smart energy and automation. COAP can be combined with AMQP to facilitate data transfer towards those constant devices and messaging based systems. And either of them can serve as publisher or consumer in the integration strategy combining AMQP with COAP. Um, when we combine AMQP with HTTP, so the request response and pub sub patterns are possible, and therefore event-driven communication can be can be handled over HTTP when combined with AMQP. Uh, Stomp is a simple text-based streaming text-oriented message protocol, which is used to transmit data across diverse application via interoperable wire format. And AMQP can be combined with Stomp to configure message interoperability among many languages, platforms, and brokers. Then we talk about the open information formats like ISO 222, which is a standard for electronic data interchange between financial institutions. And the combination of AMQP with open information formats, it ensures that the transfer of financial information, including payment transaction, securities trading, and settlement information, current debit card transaction, etc., they happen securely. Uh, then we talk about a solution which actually involves a multi-protocol ecosystem and just not two types of protocols. So in a multi-protocol system, a solution is often thought because there could be many limitations and many strengthening factors. So a proper solution can be arrived at combining AMQP with any multi-protocol system where, for example, there could be MQTT, COAP, HTTP, including AMQP and whatever else is needed to create a solution. That all is like housed together in a broader solution, and the networking and the integration follows. So that is feasible depending on the scenario. Next, we talk about Xmpp, which is Extensible Messaging and Presence Protocol. This is the XML based open communication protocol that provides robust features such as federation across domains, authentication, security for mobile endpoints. So the communication in enterprise can be combined with XMPP federation with AMQP routing and delivery. So, so there are lots of scenarios and solutions when we combine these many protocols with AMQP. Now, one more interesting thing is talking about microservices that are built using the message flow on top of AMQP. So implementing solutions using AMQP facilitates the development of small, scalable, maintainable microservices to obtain a targeted business functionality. And some of the benefits are like loose coupling, fault isolation, quick adoption of agile processes, including CI/CD, and reduced time to market. Some of the implementations which are like popular ones, and you can find more details about these in my article. I'm going to name them here like RabbitMQ, Apache Cupid, Microsoft Azure Service Bus, Red Hat AMQP, Red Hat AMQ, IBM MQ, Google Cloud Logging and Monitoring, Amazon MQ, VMware vCloud Director and vCenter Orchestrator, Cloud AMQP, OpenStack Nova, OpenAMQ, SwiftMQ, iNetCo, Solace, SAS, MuleSoft, Alpaca, Nets, Fiorano MQ, Informatica, SAP AMQP Adapter, Boomi, Software AG Web Methods and Universal Messaging, WSO2, SnapLogic, Jitterbit, TIBCO Cloud, Talent, Trade.io, Adaptress, RoboMQ. Next, we talk about the future work. Actually, we talked about multiple things. Let me summarize what I talked about. So we begin with Industry 4.0, the flood of information and technical evolutions that we are seeing around us. So basically, there is a lot of diversity. There are different kinds of solutions getting evolved. So there is a need to create a binding or create an integration. So AMQP offers the integration. Then we talked about the architectural patterns in what many ways, the architecturally a solution can be built using AMQP. And then we talked about microservices, and we talked about uh, how AMQP combines with other protocols, and we talked about a lot of solutions available industrially that many vendors have offered. And now we talk about what else is possible using AMQP. So one of the things is talking about smart city, which definitely involves again a plethora of devices which are small to big, and a lot of different uh, internet and network infrastructure. So we can harness, we can take benefit of all of that. For example, combining information flow using various data annotations, domain language in real time by using web APIs, AMQP, MQTT to link public services, for example, train, airport, mobile phone, sensor data exchange, etc. And some more future work which is like very interesting and coming forward is like autonomous computing, cloud portability, secure internet of things, hybrid application platforms, and hybrid integration platforms. So as a whole, what I want to bring home or what I want to convey is that AMQP is an area, is a network offering which is not yet properly utilized, and it can be used in many of our day-to-day scenarios, and we can really create a nice reliable, strengthful messaging solution, a way of data integration across any kind of system, whether legacy or modern, that we have, and employ a lot of different things to create a nice solution using AMQP, and there is future on top of it. So whatever we have done so far with AMQP is good, but still there's a lot that can be done on top of AMQP. So I wanted to emphasize that. So I brought up this article. Thank you. Next, I'm ready for any discussion or any question and answer session based on what I presented here. Thank you. Bye bye.